As we know, before applying the three-step procedure, we always try to reduce the provided equation into the simple form. We know that secant squared x equals 1 over cosine squared x and cosecant x equals 1 over sine x. Again, cosine squared x can be written as 1 minus sine squared x. Now, by cross multiplication, we get a quadratic equation in terms of sine x. This equation is in the form of a quadratic equation ax squared plus bx plus c equals 0. Hence, by using the quadratic formula, we can solve the quadratic equation in terms of sine x. We obtain two values of sine x. Finally, we obtained the equation in the form of sine x equals plus minus k. When sine x equals 0.847, let's apply three-step procedure to get the exact values of x. Step 1. Use a calculator to get the first answer. In this case, we get arc sine 0.847 equals 57.9 degrees. Step 2. We draw out this angle in the four-quadrant diagram. Since 0.847 is positive, the sine angle will be positive in the first and the second quadrants. Step 3. We find the angle in the second quadrant. So, the angle we need is obtained from anticlockwise rotation from the base angle of the first quadrant. Hence, we can see that the new angle in the second quadrant is 180 degrees minus 57.9 degrees, which is 122.1 degrees. Hence, the solutions for sine x equals 0.847 are 57.9 and 122.1 degrees. Now, for sine x equals minus 1.18, we will never get any solution. This is because the range of values of sine function always lies in between minus 1 and plus 1. And another reason is the provided domain in the question is from 0 to 180 degrees. It means the sine function will never have negative values in first and second quadrants. That's why our final solutions for the provided equations would be only 57.9 degrees and 122.1 degrees.
Thanks, teacher. That's a lot clearer now.
No problem. The most important thing is not to be confused with angles in degrees and radians.
Right. In case if I want a solution in radian, then we just put the calculator in radian mode and we will get arc sine 0.847 equals 1.01 radians.
That's right. So 1.01 is the first quadrant value and the second quadrant value will be pi minus 1.01 radians.
So the solution for sine x equals 0.847 in radians are 1.01 and 2.13.
Absolutely. So far it's easy, right?
Yep. It's been a blast solving questions with the three-step method.
That's great to hear. One more thing. In case if you doubt your answers while solving trigonometric equations, you can always confirm it by plotting their graphs.
The solutions given by the points of intersections of lines and the curve are much easier to visualize.
Exactly.
Finding this helpful? We have additional learning resources to offer for Cambridge IGCSE and AS A-level subjects.
Let's tackle the questions containing compound angles and multiple angles.
Sure thing.
As a quick recap, here's the summary of formulas for compound and multiple angles.
Yep, I got it. But teacher, Let's solve a question together to get everyone on track.
Sure. Let's find the solution to this question.
Teacher, it's clearly a multiple angle formula-based trigonometric equation.
Yes. And moreover, we also need to follow the three-step procedure.
Yeah, got it.
Before using three-step procedure, we need to simplify the provided equation to the simplest form, replacing sine 2 theta with 2 sine theta times cosine theta and tangent theta with sine theta over cosine theta, and by cancelling the cosine theta, we will get the expression as such. Now, we need to be more meticulous while taking the square root of sine theta in this case. Now, since sine theta can be both positive and negative, that means angle theta can be in all four quadrants. Finding the base angle theta, it should be 35.3 degrees. Then, its corresponding angles in the second, third and fourth quadrant are 144.7, 215.3 and 324.7 degrees respectively. And since the domain of x is between 0 and 360 degrees, all the four values are the solutions to this question.
So I first need to manipulate the given equations into basic trigonometric equations. Then I can move on to actually solving it.
That's right. You have understood the key idea in solving the problem now.
Yep, that's not difficult at all, teacher. Do you have any questions for me to try?
Oh, of course. Try this.
Oh, compound angle based question. No problem. Here's how I'll do it. First, I will simplify the equation. It can be done by using compound angle formula for sine. Now, cancelling the similar terms, I will get 2 sine beta times cosine 20 degrees is equal to 6 cosine beta. Since the ratio of sine beta and cosine beta gives the tangent beta, the equation can be further simplified as such. Now, following the three-step procedure, the base angle beta can be found to be 72.6 degrees. Since the domain lies in between 0 and 90 degrees, there is no need to find the angle values in the second, third, and fourth quadrants. So, the final solution that lies in between 0 and 90 degrees is 72.6 degrees.
Register now for free.